Welcome back to the workshop. I think it's fair to say this has been a very long build project over 2 years, but I'm pleased to say this is the final video on it. We've got one last job to finish off and then we can call this thing done. So I think we're on episode... what episode are we on? 39. So let's get into it. Let me introduce you to my Warco drill press. It's got a 650 watt motor, Morse taper 2 spindle, and we've got a travel on the quill of about 80mm. And under this cover we've got 2 belts configured with an idler to give 16 speed range. And we've got the usual rack and pinion adjustment for the table height. So all in all, a very powerful, robust, sturdy drill, ideal for hobbyists. But could it be improved? Well, the short answer is yes, and here it is. So there's 1, 2, maybe 3 more jobs to finish, so we'll get those sorted out in a minute. Before we do that, let's just give you a quick overview of where we're at. So we'll start right at the top there. I originally had a single phase motor, which is great. It was nice and quiet, reasonable amount of power, but obviously being single speed, what it meant was every time you wanted a different speed, you had to climb up on the ladder, open the little box at the top, adjust the belt so to change the speed between the different ratios on the pulleys, put it back down again, and then drill your hole, and then if you want to change it again, you have to repeat. So up there you can see we've got a nice 3-phase motor, and then to control that we've got a custom control box over there. And if we open it up, we open the box. So in there on the right we've got the inverter. That's the speed controller that runs the motor, the 3-phase motor, and then there's a little bit of control circuitry in there. So we've got our mains coming in, that goes up to a little power supply up there, which I think was a 12 volt supply, and then we've got little rails out there that run relays which do the fan and some auxiliary functions. And then down here we've got the motor overheat sort of relay, so if it detects the motor's getting too hot it will cut it out as just something that's built into that motor. So I decided to take advantage of that. And then you may or may not be able to see, but down the bottom here is a little inline filter for the mains, just to stop any of the inverter noise going back into the house mains. And that's kind of it. And then this whole thing, this whole box is controlled remotely by a control panel on the front of the drill. So the control cable comes in around the side and into this main box here. So on here we've got on off, we've got our independent speed control, just a little potentiometer, forward and reverse for the motor, emergency stop there. And then we've got the jog function here, up and down. So these are just momentary, so if you push it, it will spin at a set speed. So it's a defined speed that we've got set up in the controller. If you want to tap a hole, so that will tap down, and then this one's to tap back up again. So you can drive a tap in, come out a bit, clean it, go down a bit, and go at a nice controlled pace, and it only spins once you hold the jog button down and you let go, it stops. So that's basically what the control panel does. Then over here on the left, we've got a readout for when you move the quill up and down. You just get a depth setting, so if you're doing a counter bore you can go to say 10mm or something like that. So that's quite a nice handy feature, or if you go part way you can zero it off and then go a bit more, the usual thing. So that moves up and down with the quill, and then on this guide bar that also moves up and down here, there's a little flat there machined. So there's 2 functions there. One is we've got this lock off screw here, so once you get to the depth you want you can just lock that off and that stays there. So maybe you can zero that. You might be zero it there. You might be touching off a part or whatever, but it's quite nice to be able to pull that down and then just hold it that position. So that's the sort of lock, if you like. And then the other one is the depth stop, which is just a normal collar up there. So let's say maybe you've got to the depth you like, and it's about there somewhere. So an option you do also have is have a physical stop, like at that position. So you can only go that far. It stops at that point. So they're the 3 functions of this readout, and I've found that's pretty handy when you're just drilling and counter boring and things like that, or if you're touching off an edge in particular, so quite nice to have that. Then while we're over this side, I'll just also point out that so to hold the quill in line, there was a little set screw, I think it was in here somewhere, and it just pushed on the edge of it and it ran in a groove. It was okay, but there was maybe 0.5 millimetre of float, or it wouldn't always pick up on the centre of a hole or repeat, so obviously you can't have that if you're trying to be a little bit more accurate than that. So this main quill plate goes rearward and it goes onto this plate here. It's triangulated, so you'll see when I move that up and down, the quill up and down, this plate moves, it runs the DTI system or the depth indicator over here. Also moves this block up and down here, and then that runs on these 20mm linear rails. You might just be able to see them through there. There's one each side. These are the same rails that are used for the knee below. We'll show you that in a bit. And then while that goes up and down, we've also got this sort of shield plate here that helps with the bellows, that stops some of the chips going behind. So there's quite a few functions all built into one there. And again, while we're in this general area, you can see I've added this little plate here. It's a bit awkward just to get the screws in, but I managed to find 2 spare locations. This is a piece of steel, so if you're indicating or you want to centre off something, you want to put a magnetic base there and run a DTI. Obviously all this is aluminium, the cast stuff up the top here is pretty rough surface, so it didn't stick very well. So we've got a nice flat plate. I found that pretty handy there, so I'm happy with that. So one of the jobs, actually that's the third thing we need to do. Three things we need to finish off is take that off, just sand it down and give it a nice coat of paint so it looks a little bit better than that. And I guess we can't go too much further without talking about this. So we've got the digital readout. What does it read out? Well, let me show you. So let's switch this on and the machine. So we've got an XYZ readout here. The X and Y are for the table. I'll show you in a minute to move around. And then the Z is for the knee. Okay, so you can see down here I've got an XY table. I decided to buy this in the end. I did have a design for one of my own, but actually the price of this wasn't worth arguing, and I did have to make a few modifications to make it fit, because I went with these custom drive ends here. We've got ball screws on here instead of the lead screws. The lead screws are really poor quality. It came with it, they're pretty bent. And we've got a left-handed lead screw on the X-axis, so that goes the more natural way. And so you can see how that would work. As you might, it's locked off, okay. Unlock it, that might help. And then as we move it, so we've got our Y-axis in and out, and you can move that to 3 decimal places. Yeah, right. Anyway, we've got that display, and then on the X, hopefully you can see that. Usual thing. And then the other nice thing about this, because we've got the knee on it and it runs on those rails, we can do this. So to move the knee up and down, we've got a handle over here. There's a drive shaft through there, and there's a pair of bevel gears, and there's a gear at the top here that runs a ball screw that runs top to bottom, and then there's a ball nut on there, and that is connected to the knee. So when you wind this, it moves the knee up and down. Now to stop the knee falling, there's a brake system. So those of you who watched the last episode will realise that I've upgraded that because the old system wasn't very good. It didn't really grab hold very well. And we've got a much better one, so I'll show you that in a minute. And we can unlock the knee down here, and then we can wind this. I'll try and keep it in view. So hopefully you can see the readout going up and down there as we move it up and down. So we've got the knee position on top of a quill position readout as well, so between the two we can do all sorts of positional stuff. So just in case you didn't see the last video, this is the lock system. So that tube there connects to the bottom of the knee, and then there's a clamp system here. So if I loosen that, the clamp is a bit loose and it allows that to slide inside the clamp, which is connected to this tube and connected to the base. So that allows you to move the knee up and down. Yes. That's actually arrived, so that's the 4th thing I need to do. 4 little jobs I need to do just to finish this thing off. In fact, since it's arrived, you can just see it's a little threaded Bakelite ball. I went for the one with the steel insert in it. A little bit more money, but I think that'd be a bit stronger. And that should go on there. Okay, gives me a nice handle to take the brake off. So I'll keep you down here, and then just to see that in action, then I'll just loosen this off. And then we can move the knee up and down. And lock it to new position. So while we're down here talking about the knee, you can see the 2 bearing blocks here. There's 2 here and 2 the other side, and they run on this 20mm rail. That allows it to slide up and down. And if we just pan you all the way up to the top, you can see those are the same rails that also hold the quill and allow that to slide up and down. So it keeps it all nice and in the same plane. And then I guess the final thing to point out is I've done a lot of structural modifications. So the back of the machine used to stick out a long way and the motor hung below here. So I cropped that off. That allowed me to push the machine further rearward so it wasn't hanging out over the front of the workbench. And then I put the motor inverted. So there's just a little belt system in there, 2-speed system, which I think I showed you in a video, maybe the last one or the one before that. And then I've also done, because this main plate up here that holds or connects onto the casting here, comes down the sides. So we've got this pretty beefy box section down here that the rails then run on via this back plate, and then additionally that's screwed to the wall in as a lateral brace, and then a 4F one, and there's one on the other side as well. So this is pretty sturdy up here, and then the whole thing is also bolted to the bench, so it's, yes, reasonably sturdy and doesn't vibrate around too much like it did before. I also managed to get a light in here, although I think I want something better, maybe something bigger, or fill in like a light panel that sits inside here. It's reasonably bright, but as you can see, it's not the best. So I think we can do a little bit better than that, but it's a good start. And that is basically where we're at. So we've just got those last 4 little jobs to do. Although, yeah, I'm not sure I like the colour of this. The one I ordered a couple of years back when I had it my old drill was charcoal grey in the catalogue, well, online anyway, and then they sent me this colour, which is, yeah, it's okay. I decided not to do anything about it because I didn't know if it was going to be useful or whether it was something I wanted to use with this drill. Now originally the studs that came with the XY table were pretty long up here, which meant as soon as you open this drawer any distance you couldn't get anything a reasonable width, so I trimmed those down. I also had it clamped in 2 places, which meant the vice was in neither one place nor the other in terms of you know, the Y location on this XY table. So I've just bolted it down with one, and that's fully at the rear now, so it's actually quite useful. You know, I could get a bigger one, but it's okay. The other thing I don't like about it is that you see this handle, I've put these little stops on it to stop the handle dropping one way or the other. If you say down there and then you go and wind the table, it hits it, or this hits that. So actually there's 5 things to do, aren't they, because I want to make a shorter one. This will be the last video, I promise. Just let's get those 5 things sorted out. Although we have done one of them, to be fair. We've done that one, so that's kind of back to 4 again. Right, let's get on with it. Let's start here with the handle, the one we were just looking at. So I think what I'm going to do, as you can see, this has got a, and then you can unscrew like that. So it's reasonably configurable. Now I've had these little clamps on it for a while, so I think they kind of work okay, but it's too long. So what I think I'm going to do is we'll turn up some little tubes that's like a spacer that sits over here, probably about, let's have a look. Yeah, somewhere so it's reasonably clear, but good enough to get your hand on, so maybe about there. So we'll turn up a tube or a spacer that sits over that, and then we'll cut this to the same length, put another spacer there, reinstate, let's have a look. Yeah, reinstate that thread, hopefully it's a standard. So this is here, so basically it's that long, 2 inserts, job done. Bring you back in a minute. Okay, a short while later, these are the bits we got. So we've got a shortened handle. I made these 2 spacers, I've cold blew them, although it hasn't taken that well. It's not too bad. And then there's the original threaded fitting. And then we're going to hold them in place with Loctite or Loctite, honestly. Oh dear. Alright. Spacer through there. Spacer there. Okay, well, let that dry and then that should be it. Although I have just realised I did plan to paint this, so I hope I don't need to get that off to get this out. I think it will come out without disturbing this end, but we'll find out. Right, handle done. So just give it a little bit of protection. I first went over it with this zinc primer spray, And then it's onto this stuff. So this is Rust-Oleum gunmetal spray paint. It's quite pricey, about £12–13 a can, but does a really nice job. Leaves a really nice finish, and I've done most of the machine with that, so it will match that. Right, let's get it on. You do need to go easy with it, otherwise it will run, but if you leave a light coating on that, let that dry, and then put another one on, you get a really nice result. Okay, there it is, all painted. So we'll take the masking tape off, and then we can start putting it back together. Okay, we'll just get the moving jaw on first. We'll just have it loose, and then we can line it up to the fixed jaw. Looks like I can get in and actually tighten these up when it's all together. I've given these a good clean down with WD-40 and then blown them off with the air gun, so should be pretty good. And we'll keep that reasonably loose, and we'll get it lined up when it finally goes together. Right, then we can get the moving jaw on. Well, I've just got it aligned as best I can, so we'll just see how we get on with that. Let's put the screw back in. And there's the little keeper. A retaining plate. That moves okay. Alright, so how have we got on with our jaw alignment? I think we'll go with that. It's not a precision vice, that's for sure, but yeah, I can't feel any rocking, so let's put it back on the drill press. Give that a bit of a clean. And I'll dab a little bit of oil. I'll leave those loose for now because we need to dial the jaw in so it's square with the table. But in terms of... oh, that's nice. I did think if I needed to move it a lot, you know, some kind of speed handle on here would be great. But most of the time I'm using it over a small range, and I really needed this to be a lot shorter because it was completely hitting the handle below. Yeah, like that. Okay, vice done. Right, the next job is to get the vice jaw dialed in with the DTI, and you can see I've sprayed up the little, this is a bit of cold rolled steel plate that'll act as our mag base. Probably, that way's probably easiest. Drop that in there, to there. Nice. Alright, the table's a bit low, we'll lift it up. About there, I think. Yeah, it bobbles a little bit. There's some tiny little imperfections. It's not perfectly ground, but it's a very cheap import vice. I think we'll go with that. Right, vice dialed in. And that's definitely so much nicer than having to kind of clamp something on and sort of cobble something together each time. So that works really well. Okay, yeah, like that. Okay, so now we've got this far. I think it's about time we put this thing through its paces. So can we mill with it? No, we're not going to do any milling with it. This is a drilling machine, so let's get drilling something. Well, I think it's fair to say this is a fairly well used piece of material, and I won't be using that again. You can probably guess what I was doing there. For whatever reason that didn't work out. So let's drill some holes in this. This is 20mm aluminium plate. Okay, first thing we'll do, nice and easy, we'll put a spotting drill in and then we'll just drill this out to 6mm. Sort that out to 6. Uh-oh. Luckily we can move the table down without losing position. Yeah, no problem at all. Let's go a bit bigger. Okay, now this may be too much to take in one go, but let's give it a go. So I need to slow that down a little bit. Making a bit of noise. Well, it's gone through. I think in future I'd probably step up to like a 12 or 16. But, you know, it went through. It just stalled out a couple of times. So it's obviously right on the edge. If I was really doing this a lot, then I'd probably step the pulley down at the top to go into the lower range. But, you know, it can be done. All right, pleased with that. Right, let's go to the next test. Okay, next up we'll try some edge finding, some centering, and on the DRO, and see if we can drill a hole in a particular location. So we'll get our edge finder in. Table's a bit low, so what we can do here, I'll wind the table over. And then we'll pick up off this edge. What we can do there is get it in that location, then use the quill lock. Maybe a little bit lower. And we'll do the centering, so keep going till it kicks over. Somewhere there. And then this is the x-axis, so I'll zero that. Come up. Over to the other end. Down. Use the quill lock again. And do that again. Somewhere out there. So we'll do our half, and this is X, and now if we wind that back to 0, somewhere there, we'll be in the middle this way. Now we could repeat on there. Now, the reason I've offset it is because it's a reasonably good idea to pick up off the jaws unless you think your part is particularly square, and then you can repeat that on the wiring it right into the centre or wherever you want to go. So let's just mark a little hole there. Okay, we'll centre that there. And we could drill our hole as before. Let's say we want to drill another hole, let's say 30mm off to one side. We can use our readout there. Gone too far. 30. And drill there. Let's see if we're about there. Now, I can't easily measure this, but I've got the caliper set to 30mm, so just by eye we'll just see. We get that lined up in the centre at that far one. And yeah, as best I can measure 30mm. Obviously, because we've got the digital readout, we could have done it another way. There's a linear set of holes you could drill here, so you could just say every 30mm and drill a series of holes in a straight line. You could also do them in a circle, so a number of holes around a circle on a PCD. And if it was a milling machine, there's a couple of milling options you could do as well for milling on a slope or a radius. Okay, another thing we can do is drill and counterbore to suit, say, a cap head screw, and we can sink it just the right amount so it's nice and flush or just under flush. So we'll take it out with this 8.5mm drill, and then we'll run our counterbore through. Okay, here's our counterbore bit. So it's got a little pilot at the bottom, which that should fit into. And then it's got this kind of end cutting edges on here. That should open it out. And cut us a kind of flat bottom countable. Alright, let's get that in. Okay, so what we'll do, we'll get it to there, then zero off on our digital readout on the quill. Now if we want a 10mm depth, we could just bore down to 10mm, that would be an option. Or we could take it out again, move the part out of the way, take it down to 10mm and then zero it, and then come back, and then we know we're heading for zero. So, you know, a couple of ways, depends how you want to work. I'm just going to do it the straightforward way, so we'll go down to 10. And if we want to be neat about it, we could take that out, just clean up the edges. Move it over, let's see what we've got. Okay, nice. Okay, so I think the last thing we want to try out here is tapping some holes, and to do that we'll make use of the jog function. So if we just momentarily just press that, it just spins at a set speed. It's one of the parameters inside the inverter over there, forget which one it was, and then it runs at whatever speed I've told it to. So we can go either clockwise or anti-clockwise if you want to put the tap in and out, clean it, you know, if you want to do it in multiple stages. So we'll pilot this out and then put the tap through and see how we get on. Here's our M8 tap. Now it's got a square drive on it. But what I like to do with tapping in this is just hold it on the shank, and if it gets really stuck, rather than break this off, it'll tend to slip in the chuck. So we'll go with that option. And we'll put a little bit of WD-40 on it. Here we go, so we'll just jog down. Okay, simple as that. Okay, let's see if our screw fits. Okay, no problem. Well, I think that's a quick summary of all the things I think I can do with this now. So you can obviously drill some pretty large holes. That was a 1-inch hole, 25mm hole. Counterbore there to a given depth. Drilled and tapped a hole, pretty straightforward. You could do hole patterns like this, linear, around in a circle as well on a PCD. So yeah, very, very pleased. Kind of really adds to the functionality of this drill press. Like it. Right, I'll tidy this little lot up. Okay, so there we go. I think it's taken about 2.5 years to get to this point, but I'm really pleased with it. It's really added some functionality over and above the standard drill press, just having the XY table, the knee, and the ability to have the readouts on there to, you know, do some simple hole patterns and so on. It's really transformed the things I can do with this. Saves you having to go to the CNC machine and set something up there. You do something pretty quickly here. So one of the things I noticed when I was drawing this up in CAD was just how close this was going to be here. So I've gone with the shortest vise I can get, so the shortest height, and I tried to make the knee design as compact as possible in height, so I've maximised this space here. And we currently got, with the table all the way down, about 120 millimeters, or just under 5 inches, from the top of the jaw to the base of the chuck there. As I say, I knew about that in the design, but I decided to go ahead because of all the functionality I've got on here. And if I get really stuck, I can take the table off. There's a couple of bolts, it'll all come off, and that will give me quite a lot of extra travel. So the other thing I thought about was whether I could get hold of a shorter chuck. Now this one is keyless, so I think they do end up being a bit longer. It's kind of an import one, so it does have a bit of visible run out on the outer ring, although the inside's not too bad. So it might be worth investing in a name brand one, quite expensive one that maybe is shorter, keyless, and just better overall quality and longer lifespan. But it's something for the future. Then the other thing I thought about was just investing in some stubby drills, so if I get into trouble I've got some real short drills as well, or I could just buy another set and cut most of the blank end off, at least to make them a bit shorter. But I think the stubby drill will be a way to go. I think I'm going to get a set of those as well. Well, here it is. That's the end of this video. That's the end of this video series. I think we're at episode 39. Over 2.5 years in this project. Didn't think it would take that long when I started it, but we're here now and I'm really pleased because it's working really well. If you've had a project that's taken longer than you thought, give me a comment down below. I'd like to hear about that. If you've enjoyed this, feel free to subscribe. There'll be more engineering content like this to come, and see you next time.